this part two, we're going to talk about finding inverses. So finding an inverse of a 2 by 2 matrix is fairly easy. 3 by 3 gets a little bit trickier. Anything higher than that, you would do the same way as 3 by 3, which we'll talk about. But I think we'll only do a 2 by 2 and a 3 by 3. But 2 by 2 is fairly simple. So we have this formula. So we have the entries of A, which are using lowercase letters, typical, A, B, C, D. So A inverse is 1 over AD minus BC. And then what we do with the entries is we switch the A and the D, and then we change the sign of the B and the C. And then if AD minus BC equals 0, then A has no inverse. So some matrices are not invertible. And that's how you can tell if they aren't, if you can multiply those and get 0. So let's find A inverse here. And then we'll check to make sure that it actually is the inverse. So 1 over, and then of course we have A, B, C, D. So we have 4 times 3 minus 5 times 2. And then our matrix, we will switch the A and the D. So we'll have a 3 here and a 4 here, and then we'll change the sign on the B and the C. And then we can multiply these out. So 12 minus 10, so this would be a 1/2, times the new matrix that we have. And so we just multiply 1/2 times each of the entries. Whenever you have, remember this is called the scalar, but we just call it a constant or a scalar. Multiply that by each entry in the matrix. So we have 3/2, -5/2, -1, and 2. And then that should be our inverse. So we'll check this to make sure that it works. So we have 4, 5, 2, 3 times 3/2, -5/2, -1, and 2. So we have 4 times 3/2 plus 5 times -1, and then 4 times -5/2 plus 5 times 2, and then 2 times 3/2 plus 3 times -1, and then 2 times -5/2 plus 3 times 2. And then let's simplify that. So 4 times 3/2, that would be 6, minus 5, so that'd be a 1. 4 times -5/2, that would be -10. -10 plus 10 is 0. 2 times 3/2 would be 3. 3 minus 3 is 0. And then 2 times -5/2 would be -5. -5 plus 6 would be 1. So that is indeed the identity. And so that means that A inverse is the inverse of A in this case. And I'll let you check the other way, but it should work out. Like I said in the first video, if I don't think it's possible that it could work out to where you multiply A times the inverse and get the identity and then switch them and not get the identity. I don't think that's possible, but feel free to check that if you would like. All right, so now finding the inverse of a larger matrix is a little bit more involved. There's not a neat little formula to use. And so what you do is if we have this inverse here, so this is our A right there. And so this is an n by n matrix. And we're going to join the same size identity matrix, the n by n identity matrix here. And then what we're going to do is we're going to do row operations, and we're going to reduce this side to reduced row echelon form, which we'll put it as the identity matrix if it is invertible. And then whatever we get over here will be the inverse. So let's see how that works. And it definitely takes longer than doing the 2 by 2. The 2 by 2 is fairly simple. And you can do this method with the 2 by 2, but there's the formula that works pretty well too. But anything larger, there's no formula. So we just have to do this a little bit longer way. And so we have a 3 by 3. So we're going to add on the 3 by 3 identity matrix. And we're going to do row operations to get this side to be the identity matrix. And then whatever we do, we're going to treat this as one big matrix. So whatever we do to the row here, we're also doing to the row here. So it's just one long row. And then when this becomes the identity, this side over here will be the inverse. So first thing first, we will leave the first row alone. Then we need to get these two entries to be 0. So let's multiply the first row by -2 and add it to the second row. So -2 times 1, and I'm going to use a calculator just to make sure that we don't do something, simple mistake somewhere. So -2 times -2 minus 3 gives 1. -2 times -4 minus 6 gives 2. And then -2 times 1 plus 0 would be -2. -2 times 0 plus 1 would give a 1. And then this one will be a 0 since that's all we're working with on these two numbers. Then for this one, we can take 3 times row 1 and add it to row 3. So that would give us a 0 here. 3 times -2 plus 6 would give us a 0 here. 3 times -4 plus 15 would give us a 3. 3 times 1 plus 0 would give us a 3. And then 3 times 0 plus 0 give us a 0. 3 times 0 plus 1 would give us a 1. Okay, so this actually worked out pretty well. So now the next step would have been to get this one to be a 0, but it's already a 0. So we'll work on getting these two to be 0. So now we need these 3 numbers here to be 0s. So let's work on the third column here. So let's use row 3 to get these two to be 0s. So let's multiply row 1 by 3 and add it to row 3 times 4, or 4 times row 3. And so what we're doing here, because most of the times we're only multiplying one of the rows by something and adding it to another, but in this case, there's not a common factor here. So what you can do is multiply the row, for instance, multiply row 1 by that coefficient on row 3, and multiply row 3 by the coefficient on row 1. And they have opposite signs, so we can just add them. So we have, and again, we're doing the entire row. So 3 times 1 plus 0 would be 3. 3 times -2 plus 0 would be -6. 3 times -4 plus 3 would be -9. That's not right because we have to multiply by, we should get a 0 there. 3 times -4 plus 4 times 3 would give us a 0. Yeah. So we were trying to get a 0 there. So obviously we would have done something wrong. All right. 3 times 1 plus 4 times 3 gives us a 15. 3 times 0 plus 4 times 0 gives us a 0. 3 times 0 plus 4 times 1 gives us a 4. All right, now we need to get a 0 here. And we're going to use row 3. So let's multiply row 2 by 3. 3 times row 2, and then we're going to minus 2 times row 3. So 3 times 0 minus 2 times 0 is 0. 3 times 1, that would give us a 3. 3 times 2 minus 2 times 3 gives us a 0. 3 times -2 minus 2 times 3 gives us a -12. 3 times 1 gives us a 3. 3 times 0 minus 2 times 1 gives us a -2. And then we can leave row 3 alone. All right, and almost done. So now we need to get this one to be a 0. So we can multiply row 2 by 2 and then add it to row 1. So 1 plus 2 times row 2. So that would be a 3 there, a 0 here, a 0 here, because we have zeros on both rows we're working with. Then 15 plus 2 times -12 gives us a -9. 0 plus 2 times 3 gives us a 6. And then 4 plus 2 times -2 gives us a 0. And then we can leave the other two rows the same, so we don't really need to worry about those yet. We'll fix these on the next step. And then really all we need to do now is divide each row by 3, and we should be done. So we're just going to divide every row by 3, and that will give us the identity matrix over here. So 1, 0, 0, and then -3, 2, 0, 0, 1, 0, -4, 1, -2/3, and then 0, 0, 1, 1, 0, 1/3. So now we have the identity matrix over here, and this one over here should be our inverse. We'll check it. Well, we don't really have room to check it. We'll assume that it's right. Actually, I can do this real quick on the calculator just to make sure. And it looks good. Okay, so that one's correct. All right, so you have to be very careful. For instance, I almost did make a mistake, I think right there. So it's very easy to make one mistake and then the whole thing is going to be messed up from there. So, all right, we'll stop this one here and we'll finish up on the next one.